Hi, I'm Matthew Bascom, and this is Graph Factor. This is my XORPD series where I walk you through explanations of XORPD's famous opcode book, Exchange RAX. Let's get started. The XOR instruction is a bitwise operation that performs an exclusive OR on two operands. It compares each bit of the first operand to the corresponding bit of the second operand and sets the corresponding bit in the destination operand to 1 if the two compared bits are different, or 0 if the two compared bits are the same. In challenge hex 4, AL stands for the lower byte of the EAX register. Hex 20 is equal to 32 in base 10, or 00100000 in binary. In this application, the XOR essentially toggles the fifth bit of EAX and stores the result in EAX. The obvious application of this operation is to change the case of letters in the ASCII alphabet. For instance, consider the numeric value for ASCII character capital Y, which is 89 in base 10, 59 in hexadecimal, and 0101 1001 in base 2. Similarly, lowercase y is 121 in base 10, 79 in hexadecimal, and 0111 1001 in binary. By doing an XOR with a hex 20, or 00100000 in base 2, you can toggle the capital Y to a lowercase y and vice versa. Recall that the challenge performs the XOR of AL with hex 20. The reason only the lower byte of EAX is considered is because ASCII values are expressed using only one byte. Next, I'll confirm these values within GDB and step through the program. Since the application here is relatively simple, I'll spend some time walking through the system calls used in assembly that are necessary to collect user input and print output to the screen. This assembly program takes a single ASCII character, performs an XOR against its numeric value, and prints the result to the user. Line 10 starts by defining a few variables necessary for printing data to the user, such as informational strings and their sizes. Also note that at line 11, the input variable is defined as a single byte parameter, denoted by dB, initialized to 0. At line 20, we see the start of the program. This is also sometimes referred to as main. Line 23 begins preparing registers to print a prompt to the user. The interrupt service routine for the syswrite system call is designated by placing the number 4 into EAX. Syswrite requires an additional parameter specifying standard output with the number 1 placed into EBX. Moving down to line 32, we see that several parameters are established for the requisite sysread system call. EDX holds the size of the data to be read, which is 1 byte. The input variable is moved into ECX because that's where the sysread system call will place data received from the user. And EBX and EAX show that data will be received through standard input using the sysread system call. Once the interrupt instruction hex 80 is called and the processor has switched to kernel mode, the value in EAX specifies a sysread operation to read data from stdin. The return value of sysread is stored in the EAX register. In this case, the return value is the ASCII character entered by the user. take note of line 42, which includes the XORPD challenge code XOR AL hex 20. Just before the XOR operation, the address of the input variable is placed into the lower byte of EAX. After the XOR, at line 43, the modified value of AL, that is the lower byte of EAX, updates the input variable by moving the updated value of AL into the input variable. The remainder of the program prints the modified character to the user and returns control of the processor to the operating system. Next, we'll open the program with GDB. We see that we have our start there. We're going to set a break at start. And we're going to stick with our previous sample character, the letter Y. And looking at the character values, just for confirmation, we've got hex 79 is equal to lowercase y, and hex 59 is equal to uppercase Y. And we're going to try a couple new things today. We're going to put layout as assembly, and we're going to display the three subsequent operations after the program counter. Now that we've hit our first breakpoint, the first instruction that happens after the start function is moving the hexadecimal value 1B into EDX. That corresponds to line 23 on the assembly code on the left-hand side. And 1B happens to be the length of the string defined on line 12, or 27 bytes. Single stepping through the program now, we see that the address 402.0.0.1 is being moved into ECX, and that corresponds to the address of the string variable. And we can inspect it like that, enter a single character. That's what is sitting at that address. Recall that the next two lines correspond to the file descriptor for standard output and the syswrite system call. So we're going to step through those, and we're going to call the interrupt service routine with hex 80. And then we're going to continue down. We've got one placed into EDX. We've got the address of the input variable at 402.0.0.0 being placed into ECX. And these two lines correspond to line 32 and line 34. So we're going to do the next instruction again. We've got the 0 going into EBX, the file descriptor for standard input, the system call for sysread 3 being placed in EAX, and the interrupt service routine being called, which will prompt us now for input. In this mode, GDB doesn't actually show us the input prompt, so we're just going to enter the letter Y, and we're going to hit enter. And our very next instruction is the XOR AL hex 20, which corresponds to line 42. And since it's about to change, we're going to inspect EAX. It's currently hex 59, which is uppercase Y. And we perform the next instruction. We look at EAX again. It's now hex 79, which is lowercase y. One reason I think this program is interesting is because EAX is used not only to modify the user input using its lower byte, AL, but it's also interesting that when the system call hex 80 is called and the program enters kernel mode and control is passed to the kernel system call handler, the value in EAX determines which system call to execute. That's all for this challenge. If you've watched this far, please comment, like, and subscribe. See you next time.